I am going to graph this polynomial. It's in factored form. But what's interesting is it's not completely factored. Do you guys notice that's not factored all the way? Could you remember a difference of squares and factor that? Hopefully you remember back from when you did quadratics, when you factor that, what that becomes is really x minus 3, x plus 3. It's called a difference of squares. So what you want to realize is this is really x minus 3, x plus 3. These are the same. That is the factored form. So really you have all these zeros. And it also affects your degree. For instance, your degree is not going to be a 1, a 1, a 1, and a 1. So 1 plus 1 plus 1 plus 1 is 4th degree. My zeros are going to be, well, what makes that 0? What makes x 0? Isn't that 0? Since x is by itself, what makes x 0? It's 0. If you plug 0 in, it would be 0. So what makes this 0? There's my second 0. Well, wouldn't it negative 4 make that 0? What makes this 0? Wouldn't that be positive 3? And what makes this 0? Negative 3. Now, another way to find your zeros is you could technically take this, watch this, and set it equal to 0 and solve it. Watch this. It's kind of interesting. If I set that equal to 0, watch, you actually get the same zeros. Add 9 to both sides. Square root both sides. Don't you get the zeros of negative 3, positive 3? So you could technically set this equal to 0 and solve it, or you could factor it and see it in factored form. It's whatever makes you happier. You have to be able to kind of see it in either format, factor it, or solve it. Your call. Okay, 4th degree, 3 zeros. Let's mark those zeros down. So we got a 0 here at 0. We got one at negative 4. We have one at negative 3. And we have one at positive 3. There's 4 zeros. Our end behavior. Well, since it's a negative lead coefficient, isn't that a negative right there? And 4 is even. Since 4 is even, what that means is it's negative, so we want the right side to be dropping. And since it's even, we want both sides to go the same direction. So what that means is I go up here, and I know this is going to be dropping on both sides. So I know I'm dropping on both sides. And now I got to draw the curve through it. Now, my max will be very low here, so I'll hit a little max right there. This one, I'm going to say is going to hit right here. Again, I don't know where it's going to hit. I'm just going to put it there. And this one, I'm going to put up here, just for the heck of it. Just put it right there. So I made my own maxes and mins, kind of curving it through. Nothing's contradictory here from what we see. Nothing should contradict. So our last thing is just label our maxes and mins. So that's a max. That right there is a min. And that right there is a max. And then we could actually put a coordinate as well if we wanted to. So if we want to, let me see, I'm going to go with negative 3.5, comma 1, negative 1, comma negative 3, and 1, comma 1, 2, 5. I'm just trying to be more detailed. Do I know for sure that this is how high and low my maxes are? No. Could you plug a number in, say negative 1, to see how low that dot actually is? Yeah. All I know is somewhere between here, we want to have a minimum. Somewhere. We don't know, but I just know it, generally speaking, looks something like that. And that's what we're looking for, a general sketch. We know for sure the edges look like this. We know for sure those are the zeros. The rest of it, we don't know. It has a negative 2 here, so that does mean it's a little bit, that the max and mins are going to be a little bit higher than just a negative 1. Because again, the bigger the number is right here, the higher the maxes and mins are. That's something to be aware of.